In yesterday's derivation, the first derivation was Lorentz force. Lorentz force means, suppose if a charge is placed in the electric field, only electric field, the formula is what? F is equal to Q into E. If the charge is placed in only magnetic field, and in magnetic field, the formula is what? FB is equal to what? Q into V cross B. Okay. So what the formula is what? The formula is equal to what? QBB sin theta. So what is Lorentz force? If the charge is placed both in electric and magnetic field at the same time, the formula is F is equal to what? FE plus FB. Clear? So that will become what? F is equal to Q into E plus Q into V cross B. So the formula is what? F is equal to Q into E plus V cross B. This is the formula for the force when the charge is placed both in electric and magnetic field at the same time. Now, the second derivation was what? The second derivation was magnetic force on a current carrying conductor. So when you place a current carrying conductor in the magnetic field, the formula is what? F is equal to BIL sin theta. BIL sin theta, where B is the magnetic field. See, magnetic field is measured in what? Magnetic field is measured in? Yes, anyone? Magnetic field is measured in what? It's measured in Gauss or Tesla. Here, it's measured in Gauss or Tesla. So 1 Gauss is equal to 10 to the power of minus 4 Tesla. 1 Gauss 10 to the power of minus 4 Tesla. This is the value. So magnetic field is measured in Gauss or Tesla. Next one. So here, what is the formula? F is equal to BAL sin theta. L is the length of the conductor. How much portion of the current carrying conductor is placed in the magnetic field, not the whole conductor. How much length of the conductor is placed in the magnetic field? That is L. I is the current, B is the magnetic field, and theta is the angle. What is the angle? Angle between the current carrying conductor and the magnetic field. How much is the angle? That is theta. So F is equal to BAL sin theta. Third one is what? When you release a charge in the magnetic field. So suppose when I speak about this one, what is the meaning of this cross and dot? The current is coming out. Which one? Suppose A and B are the two things. So which one is coming out and which is going into the board? Which current is coming out of the board and which one is going into the board? Yes. Yes, which one is coming out of the board and which is going into the board?
The dot is coming into the board. A is coming into the board and B is coming out of the board.
A is coming out of the board. B is going into the board. Understood?
Oh, yeah.
Keep that in the mind. It's like an arrow, tip of the arrow. It's like a tip of the arrow. When the arrow is coming towards you, you can only see the tip. When the arrow is going away, it will be cross. Okay. Clear. So when the arrow is coming towards you, it is A. When it's going into the board, it is B. Clear? Now, so motion in a magnetic field. So here what happens? The formula for that, when you release a charge in the magnetic field like this, so what happens? Exactly 90 degrees, it goes into the circle. So it goes into a circular path with the radius R. Clear? The formula is R is equal to mv by bq. So what is the formula for time period? Time taken to complete one rotation. T is equal to what? 2 pi m by bq. The formula for that is what? The time period formula is T is equal to 2 pi m by bq. Now suppose if the charge is not released at 90 degrees, it is released somewhere at an angle theta. Then what happens? The charge will go in a spiral path or helical path. So there only in helical path we can calculate the pitch. Pitch is equal to what? V parallel into capital T. Okay, pitch is equal to V parallel component. Pitch P is equal to V parallel into capital T. V parallel is the parallel component of the velocity and T is the time period. Is that clear? And the third one is what? Next derivation was motion in combined electric and magnetic field at the same time. Did you understand? Yesterday's class we were doing that, and this was a derivation. When suppose along x-axis there is a velocity of the charge particle, along y-axis we have electric field, and along z-axis if we have the magnetic field, the formula is what? F is equal to what? Fe plus Fb. F is equal to Q into E. that is Q into V cross B, take Q common. We have electric field. Electric field is along y-axis, velocity is along x-axis, magnetic field is along z-axis. So F is equal to Q into E plus Q into E J cap. And magnetic field Q into V cross B. So Q into VI plus BK. I cap is along x-axis, I, J, K are unit vectors along x-axis, y-axis and z-axis respectively. I cap unit vector along x-axis, J cap unit vector along y-axis, K cap unit vector along z-axis. So Q into V cross B, VI plus BK. So I cross K is equal to J minus J. Okay. Now take common, then take Q common, we get that value. And suppose if F is equal to 0, what we can write? E minus VB is equal to 0. E is equal to VB, V is equal to E by V. Okay. So this is about what you call the concept, that is said to be the velocity selector. So it's like a ratio. Okay, suppose if you want to find out the ratios, generally E by M ratio is used in spectrometer experiment. Spectrometer experiment is used for what? It is used for isotopes. Okay, that experiment is used for isotopes. Suppose if you want to if you want to, like, we have like in a element, like if you take a element from some element or some substance from the earth crust, example maybe a chlorine or carbon something, it has isotopes in it. Maybe if you take 1 kg, maybe 999 grams, maybe one substance, maybe C612. Okay, and the remaining will be C613 and 14. So how they separate? They get separated using we get it separated using spectrometer experiment. E by M ratio is an important parameter in electricity. Okay, so it is 1.76 into 10 to the power of minus 12 coulomb per kg. That's an important value. Clear? Is it clear, all of you?
So can you explain that last part again?
So E by M ratio, E by M ratio is the amount. Suppose if you are taking maybe 100 grams of a substance, maybe carbon or maybe chlorine. Carbon has 3 isotopes, C612, C613, C614. Okay, these are the 3 isotopes. So maybe C612, we have 99%. And C613 and 14 maybe only not even 1% also altogether. So that can be separated. These 3 isotopes can be separated using experiment in a spectrometer. Okay. Clear?
Yes, sir.
Yes, sir.
Now, going to the next one. Now we have 2 laws. Okay, magnetic field due to a current element. So magnetic field due to a current element. Magnetic field due to a current element. So what will happen now? Now here we have 2 laws. Okay, one is what? BSL, and second one is ACL. But BSL is not, suppose we want to find out the magnetic field around a current carrying conductor, maybe a long wire, or maybe a coil, or maybe a solenoid, or maybe a toroid. You want to find out the magnetic field around it. So there are 2 laws which they have explained. One is Biot-Savart law, one is Ampere-Circuit law. Okay, there are 2 laws. One is Biot-Savart law, the second one is Ampere-Circuit law. These 2 people have explained about the magnetic field around a current carrying conductor. Now it says that, like, suppose in the Biot-Savart law, we'll go with Biot-Savart law. Okay. In Biot-Savart law, it says that, suppose this is a current element. Okay, X and Y. This is a current element, and I is the current. Okay, DL is a small element. And now there is at this point, I want to find out the magnetic field at this point P. Maybe this is the P is a point. At point P, I want to find out what is the magnetic field. It is a small element. Okay, not this much also. I will take small element like this. Small element. Okay, the distance from this is R, from the wire to that parameter is R and the magnetic field is dB. Okay, so now this is what this small piece is said to be what is said to be current element. Current element that is said to be DL. DL means small thing, small wire. I is the current. So altogether, if you multiply both, we get current element. I into DL is said to be current element. R is the distance. I want to find out the magnetic field at point P, which is at a distance R from the wire, from a current carrying wire. Okay, and theta is the angle. Okay, theta is the angle between the current carrying wire and the distance. So the formula is what? dB is proportional to what? dB is proportional to I into DL cross R. Okay, divided by R cube. So the magnetic field is directly proportional to the current element and the distance. That is square of the inversely proportional to the square of the distance. Means as the distance increases, magnetic field. As the distance increases, magnetic field will decrease. As you're going away from the wire, magnetic strength will decrease. So now what we are writing to remove the proportionality constant, we are writing mu 0 by 4 pi. Okay, mu 0 by 4 pi into I into DL cross R divided by R cube. Okay, I into DL cross R by R cube. Now here we are writing dB is equal to what? dB is equal to mu 0 by 4 pi into I into DL divided by R square. So I DL sin theta by R square. Okay, sin theta divided by. So this will become divided by R cube. So this and this will go away. So dB is equal to what? Mu 0 by 4 pi into I into DL sin theta divided by R square. Okay, so this is the formula. Is that clear? Mu 0 by 4 pi I into DL sin theta by R square. So what is the mu 0 by 4 pi value? Mu 0 by 4 pi value is equal to what? 10 to the power of minus 7. Okay, in Tesla meter per ampere. The value for this is, okay, mu 0 by 4 pi value is 10 to the power of minus 7 Tesla meter per ampere. Once again, see here in Biot-Savart law, what he is saying is there is XY is a wire and IDL is a small, IDL here is a small current element, and theta here, theta is an angle. Now what is the distance from here, from the current carrying wire to this distance is what? P, that is R. P is the point, dB is the magnetic, small magnetic field we want to find out. dB is proportional to I into DL cross R divided by R cube. So I into DL cross R by R cube. Now here I into DL, IDL R sin theta divided by R cube. R and R will go away. We are left with this one. What is mu 0 here? What is the meaning of mu 0? Okay. What is the meaning of mu 0? Mu 0 is said to be permeability of free space. Permeability of free space. What is permeability of free space? It is a property of the medium. It is a property of the medium which allows magnetic field lines to pass through. It is a property of the medium which allows magnetic field lines to pass through. 4 pi into 10 to the power of minus 7 Tesla meter per ampere. This is the value for mu 0 value. Now, so now this is the value. So therefore, we will.
Sir, can you explain the difference between permittivity and permeability?
Same, both are same. Permittivity is only for electric lines of forces and permeability for magnetic lines of forces or magnetic field.
Okay, sir.
That's the only difference.
Okay, sir.
Now, so here we have a magnetic field on the axis of the circular loop. Next derivation. Quickly copy this one, then we'll go to the next one because it needs the whole board. Okay, this is a derivation now. So otherwise we have to do half of at one time.
Done, sir.
Okay, then
So almost done.
now next one is what?
So 2 minutes.
Okay.
So done.
Okay, magnetic field on the axis of the circular current loop. So it comes under Biot-Savart law only. Okay, so we are still doing the Biot-Savart magnetic field on the axis of circular current loop. and on the axis of circular current flow. Magnetic field on the circular current flow. So suppose this is the wire, and we have this is x-axis, this is y-axis, and this is z-axis. Okay, x-axis, y-axis, and z-axis. So this plane of wire is this loop current carrying loop. This is the current carrying loop. Okay, this is the current flowing in the loop, and this current carrying loop is in YZ plane. This loop means the circular wire. Okay, in the form of a wire in the folded in the form of a circle. This loop is in XY plane. Okay, it is in YZ plane. It is in YZ plane. Okay, now so magnetic field is along x-axis. So therefore, this is a small current element. Here there is a small element. The current element is there. So we are writing here IDL. IDL is a small current element. Because of this current element, I want to find out the magnetic field here at this point P. I want to find out the magnetic field at point P. Okay. So here it is what? This is X, this is X-axis, this is Y-axis. Okay. So we are writing here, if this is dB, this is dB. We can write here, this is dB parallel. This is dB parallel or dBx. We can write along X-axis, and this is dBy, which is along Y-axis. Clear? See, this is the magnetic. What will happen? As per the you can write right hand thumb rule. Suppose this is the current. This is the current carrying conductor. See here. If this is the current carrying conductor, like current, this is the current. Thumb is the direction of the current. Then curled finger shows the direction of the magnetic field. So the magnetic field is in this way. So magnetic field is in this way. So the magnetic field is in this way. So magnetic field will go here. It is on the x-axis. So what happens? We have dB and then dB x-axis and dB y-axis. So what will happen? dB is equal to what? Mu 0 by 4 pi. The formula for this is what? dB is equal to what? Mu 0 by 4 pi into mu 0 by 4 pi into I into dl cross R. Okay, that is the formula. Already we know that. I into dl cross R by R cube. I into dl cross R divided by R cube. This is the formula. So here, what is that? The distance between, here we have R is equal to, this is R is capital R is the radius, X is the distance from the center of the wire to the point P, and small r is the distance from the current element to point P. Once again, see here, R is the radius of the loop, X is the distance from the center to point P, and R is the distance from the current element to point P. Now, if I use the Pythagoras theorem, it will become R square is equal to what? X square plus R square. Okay, X square plus R square. Now here, what happens if I write here I into dl sin theta, because they are perpendicular. This magnetic field is perpendicular to the R and this plane, both are perpendicular. So we can write IDL R sin theta. So that will become sin 90 degrees. So this will become mu 0 by 4 pi into I into dl divided by R square. Okay, I into dl divided by R square. Now in the place of R square, I'm going to write the whole thing. In the place of R square, I'm going to write this value. So what happens here? dB will be equal to how much? dB will be equal to mu 0 by 4 pi into I into dl divided by X square plus R square. No need to write whole square, because this is in R square value is X square plus R square. This is the value. So let it be, let this be equation number 1 and let this be equation number 2. Okay, let that be equation number 2. Now we have X component is along dB and Y component is along dBy. Okay, so here what happens? X component is along dBx and Y component is along dBy, or we can also write dB perpendicular. Okay, dBy or dB perpendicular. So therefore, what happens? dBx is equal to, we can write here dBx is equal to what? dB cos theta. dBx is equal to what? dB cos theta, and dBy is equal to dB sin theta. So here, if you want to find out the cos theta, here, if I want to find out cos theta, so this is theta. Now, what is cos theta? Adjacent side by hypotenuse. Adjacent side by height. So this is the angle. Theta is the angle here. So if you find out cos theta here, cos theta is equal to what? Adjacent side by hypotenuse. What is hypotenuse? R. R is equal to how much? Under root of x square plus r square whole to the power of 3 by 2. Cos theta is equal to r divided by x square plus r square whole to the power of 3 by 2. That is equation number 3. Okay, that is equation number 3. So from 2 and 3, so we are going to substitute equation 2 and equation 3. From here we will write now what is, we have to find out now dbx. So because dby is perpendicular, which is of no use, is perpendicular, but the whole magnetic field is along due to the x-axis. Okay, so now what happens? dB is equal to what? So here what happens here? dbx is equal to mu 0 by 4 pi into I into dl divided by x square plus r square into r divided by x square plus r square. Okay, whole to the power of, so sorry, this will become 1 by 2, not 3 by 2. So this will become 1 by 2. So the total value will become how much? dbx is equal to what? Mu 0 by 4 pi into I into dl into r divided by how much? X square plus r square whole to the power of 3 by 2. Now we know that x is much greater than r. X is much greater than r. So this will, what will happen now? dbx is equal to what? Mu 0 by 4 pi into I into dl divided by x square whole to the power of 3 by 2. Okay, so this and this will go away. We are remaining with dbx is equal to what? Mu 0 by 4 pi into I into dl divided by x cube. I into dl divided by x cube. Or we can also write here if you want to find out the full element. Okay, this I will not take in this way. I just try to reduce it in this here itself. Suppose if I want to find out the I'll not take like this. I into dl. Let it be like that. So magnetic field I'll try to find out the full magnetic field. The full magnetic field I have to write here as mu 0 by 4 pi. Here it will become L. L will become 2 pi r. Why? Because that is a perimeter of the L is equal to 2 pi r is what? Perimeter of the circle. Perimeter of the circle here is 2 pi r. So into 2 pi r into r divided by x square plus r square whole to the power of 3 by 2. So, so what will happen now? So, so that will become that also it is along x-axis. Okay, dbx is along x-axis. This is along x-axis. So if I cut this one, that is here, this will become see this 2 pi and this will become 2. That will become 2. So x is much greater than r. So here what will happen? Bx is equal to what? Mu 0 by 2 into I into r square divided by x square plus r square whole to the power of 3 by 2 I cap. Whole to the power of 3 by 2 I cap. Now if x is equal to 0, if the distance at the center we want to find out, if x is equal to 0, what will happen? Bx will be equal to what? Mu 0 into I. So see, when x is equal to 0, this will become r cube and this will become r square. Only r will be left. So 2r, that is a formula. Mu 0 I by 2r, that is a formula. If you want to find out the magnetic field at the center here. If I want to find out the magnetic field here, this is the formula. Is that clear? Once again, see from the beginning, this is a current carrying loop. Now the loop is in YZ plane. The loop is in YZ plane. So once again. So the loop is in what? YZ plane and the magnetic field is along x-axis. So we have r is the radius of the loop and x is the distance from the center to point P and r is the distance from the current element to point P. IDL is the current element. Now dV is equal to, here we have dV, dVx and dVy. Parallel and this is perpendicular. dV is equal to mu 0 by 4 pi IDL cross r divided by r cube. R square is equal to what? X square plus r square. Now I into dl divided by r square will be left. Now what I am doing here, if you take, this is the r square value is what? R square value according to this one, just substitute that value. And we have two components, dvx is equal to dv cos theta. Cos theta you find out, theta is the angle here. dvx is equal to mu 0 by 4 pi I dl x square plus r square. Cos theta, you substitute there. Then we get x square plus r square whole to the power of 3 by 2. Now this is the total value. So mu 0 by 2 I r square divided by x square plus r square whole to the power of 3 by 2 into I cap. If x is equal to 0, bx is equal to mu 0 I by 2r into I cap. Is that clear? Is that clear, all of you?
Yes, so
This is at the center of the loop. This formula is for the center of the loop. Okay. So they can ask a numerical also on this. So be clear with this. I'm giving you some time. Just copy this. Ampere's circuitous law says that integral is equal to mu naught times the current passing through the surface. So the magnetic field is here. The magnetic field is integral is equal to mu naught times. So closed integral b dot dl is equal to mu naught I. This is the formula. If I want to find out the magnetic field around a current carrying conductor, then I have to use this formula according to Ampere's circuitous law. So he says that suppose if this is a wire, this is a current carrying wire, around it there is a magnetic field. This loop, okay, this circle, I is the current in the wire, B is the magnetic field. This is said to be Amperian loop. Okay, this is said to be Amperian loop. Okay, that loop is said to be the Amperian loop. Now, so B, I is the current, B is the magnetic field. Clear? So now, so that is here. Suppose if you want to find out the magnetic field, this I will write for a current carrying wire. Current carrying wire. So I is equal to what? Closed integral, that is B is the magnetic field and the loop is said to be Amperian loop. Okay, so here we have closed integral B dot dl is equal to what? You have just write same formula. Closed integral B dot dl is equal to mu 0 into I. So integral closed integral dl is equal to L. It will become L, which is equal to what? 2 pi r. 2 pi r is the perimeter of the circle or perimeter of the magnetic loop. Okay. So now what happens here? B into 2 pi r is equal to what? Mu 0 into I. So just cross multiply this one. The formula is what? B is equal to mu 0 I by 2 pi r. Is that clear? Did you understand now? If it is a straight wire, I want to find out the magnetic field around the loop at a distance r. Then what is the formula? B is equal to mu 0 I by 2 pi r. Is that clear, all of you? No one is replying. Is this clear?
Yes, sir.
Now, next one is what? Solenoid. We'll go to solenoid and then toroid. I think toroid they removed from the syllabus. No. What is a solenoid? Anyways, we will do solenoid and toroid both. Okay. What is a solenoid? Solenoid is a long helical wire. A long helical wire. Okay, where length is much greater than the radius of the loop. Length is much greater than the radius of this one. Okay, and they are very closely packed, and they are enameled. We are using enameled wire. It's a hollow circular ring. Sorry. Its length is much greater than the radius. It consists of long wire wound in the form of a helix. Okay, it is in the form of a helix. Mohammed 6:30. Abhi 6 o'clock or hello. Now, so here we have what? It consists of long wire wound in the form of a helix where the neighborhood turning are closely spaced, and the next one is enameled wire is used for winding so that turns are insulated from each other. Okay, so here what is the formula now? B into L is equal to mu 0 and I. Okay, so the same formula we are using. B into L is equal to mu 0 into I. Okay, we are using this formula. Okay, same formula, mu 0 into I. But here what we are writing, IE is the, here if you are taking H is the current length of the, or L is the length of the current, if you think. So what is N here? Number of turns per unit length. N is number of turns per unit length. So what we are writing, enclosed current is what? IE is said to be the enclosed current. Enclosed current. IE is said to be the enclosed current. So B into L is equal to mu 0 into IE. So here we have B into L is equal to what?